Hello everyone. Our topic name is Predictive Analysis of Bank Market Campaign. My name is Rakesh Kumar Busa and my teammate name is Sayanish Nimalkanti. Introduction. Let's start by understanding the problem. So bank spends millions every year on direct marketing campaign for term deposits. The expectation usually is to attract more clients to subscribe to these deposits. However, the reality is often more disappointing. These campaigns see very low subscription rates. But why? Often these campaigns are not targeted effectively. Resources are spent reaching out to clients who are unlikely to subscribe, while clients who might be interested are overlooked. So in our project we are trying to address these challenges using by machine learning. By predicting client responses, we aim to help banks in terms of improving campaign targeting and allocating resource more efficiently so that ultimately increase the subscription rates. For this to achieve this, we compared multiple machine learning models in our analysis and identified the most effective ones to do this task. Our finding highlights the practical strategies to reduce waste and improve marketing outcomes. Data overview. We got this dataset from machine learning repository, and this is like Portuguese bank dataset, and it had 40,000 rows and 21 columns. The target variable Y indicates whether a client subscribed to term deposit or not. Most of the data, 88.87 precisely, are labeled as no, while only 11% are labeled as yes. This shows a clear class imbalance. The features are mix of categorical and numerical. We had like 11 categorical features like job, marital status, and education, etc., and 10 numerical features like age, duration, and campaign highlights and P days, etc. So this imbalance presented a major challenge. Without addressing it, our machine learning models would be biased towards predicting the no, which is the majority class. Additionally, working with the mixed data types means we need to tailor the pre-processing methods to handle categorical and as well as the numerical features effectively. It is also worth noting that the dataset contained no missing values. This was really helpful as it is allowed and gave us more time to do pre-processing tasks effectively.
So for data preprocessing, after we found that there were no missing values in the dataset, we moved on to detect the outliers because outliers can skew results and affect the model's performance. So we use blocks plots to detect the outliers in the numerical features. For example, like extreme values in duration or age could have biased our predictions. So we clipped these outliers by capping the values at 1 and 99 percentiles. After this, we focused on encoding the categorical features. So we found that there was only one ordinal categorical feature in the entire dataset, which was education. So we used numerical encoding to encode the ordinal dataset, and for the other features, we used one hard encoding so that these features could be easily used by the machine learning models. So we use Smooth to address the class imbalance in the target variable, and using Smooth, we generated synthetic examples for the minority class, which is yes, so that the models could learn easily from a balanced dataset. And after splitting the data into testing and training sets, we use Smooth on the training set to make it more balanced. And then we moved on to numerical variables and we use standard scaler to scale the numerical variables so that the algorithms like logistic regression and MLP could perform better by removing the scaling differences. And finally, we did correlation analysis using a heat map using Seaborn library. And in that, we observed that the duration showed a strong correlation with the target variable, which making it one of the most important predictors.
Data exploration visualization findings. These are the insights we gained during the data exploration phase. We used heat map and distribution plot to analyze the correlation and the target variable analysis. As we told earlier, we found a big imbalance between the target variable classes between S and no, and we did smooth as well. And with the correlation mapping, we found out that the target variable is highly correlated with the duration, and whereas it had like a very less negative correlation between the campaign and previous columns. So this heat map guided our feature selection, and by focusing on highly correlated features like duration and Eurobarium, we could improve our model accuracy and efficiency. These steps were critical to preparing the data for modeling. Methodology. After completing all data cleaning and preprocessing steps, we divided the data into training and testing sets in 80-20 split. Then we ran our models with the train and test splits. Logistic regression. This worked as a baseline model for comparing the metrics, as it is very simple and interpretable and works well with the linear relationships. We configured it with as a max iterations as 1000 to ensure the convergence. And as you can see, the results were accuracies of 88% and we got F1 score of 93%. And this shows that it performs well as a baseline but may struggle with non-linear parameters. Random forest. This ensemble method captures feature importance and handles non-linear relationships. We configured it with the 100 estimators and a maximum depth of 15, and the results got accuracy as 90% and F1 score as 94%, and it shows that it balances the bias and variance well, and the random forest is very much suited for high dimensional data.
Shows gradient boosting because of its high predictive power, and it can also capture complex patterns in the dataset. And we set up its parameters at estimators at 200, and we selected a max depth of 12 and a learning rate of zero point 0.2 for it. And using this, we got accuracy of 91% and an F1 score of 95%. Gradient boosting was our best performing model so far. And then we moved on to native bias. We selected native bias because it assumes feature independence and we want to test it on our dataset. And while it's good, we found that this assumption limited its performance on our dataset, resulting in accuracy of 72% and an F1 score of 82%. And then we chose MLP, multi-layer perceptron, because it captures complex non-linear relationships. And we experimented with different configurations, and we finally finalized on hidden layers of 100 and 150 and the activation function ReLU. And using this, we got an accuracy of 90% and an F1 score of 94%. And this model captured the nonlinear patterns in our dataset very effectively. But gradient boosting was our best performing model out of all of them. We performed ROC curve analysis to see how the models were performing in distinguishing the multiple classes in the target variable. So in for random forest, we found that it handle the nonlinear relationships very well, achieving a ROC AUC score of 0.94. So it does this by building multiple decision trees and averaging their results. So it effectively captured the complexity of features like duration, which strongly correlated to the target variable. And for gradient boosting, we found it also performed very well with a AUC score of 0.94, and logistic regression achieved an ROC AUC score of 0.92. It did well in capturing linear patterns, but it didn't perform well effectively in capturing the nonlinear relationships in the dataset. And for MLP classifier, Using the hidden layers of 100 and 150 and the activation function ReLU, it performed very well in capturing the nonlinear relationships in the dataset. It worked particularly well after we performed pre-processing steps like smooth and standardization, resulting in it achieving a AUC score of 0.91. But we found that native bias didn't perform well on our dataset because of its assumption of feature independence, which resulted in an AUC score of 0.77%. So, in conclusion, we found that random forest and gradient boosting perform exceptionally well for our model, both achieving an ROC AUC score of 0.94%.
Conclusion. This project highlights how machine learning can bridge the gap between resource heavy marketing campaign and efficiency. Key findings: random forest and gradient boosting both performed well, and they were the top performers with ROC and AC scores of 0.94, and they showed their ability to handle complex and nonlinear relationships. Logistic regression served as a strong baseline model with a score of 0.92, but it was limited by its linear nature. The MLP model matched the ensemble methods closely with a score of 0.91 by providing its strength in capturing nonlinear patterns. Naive Bayes provided computational efficiency but struggled with datasets complexity due to its independence and assumptions. By predicting client responses with high accuracy, these models enable banks to focus their resources on the right audience. Also, by doing this, so reducing waste and efforts, maximizing return of investment. This approach transforms traditional marketing strategies into data-driven and decision-making processes. The results highlight the importance of advanced ensemble methods like random forest and gradient boosting in achieving high predictive accuracy for campaigning effectiveness.
Thank you.
Thank you all.